This research paper investigates the perpetuation of sexual identity stereotypes in large language models, LLMs, and proposes a post-hoc debiasing method to mitigate these biases. The authors focus on representational bias, which occurs when a system negatively portrays a particular demographic group, leading to a lower social perception compared to other minorities. They use the regard score, introduced by Sheng et al. 2019, to quantify this bias. The authors perform a comparative study of how LLMs generate text describing people with different sexual identities. They create gender-neutral biographies and prepend them with trigger words indicating the sexual identity of the subject. The results show that the LLMs yield biased outputs, measured by a lower regard score, when the trigger words indicate a queer sexual identity. To address this bias, the authors propose a post-hoc debiasing method based on chain-of-thought prompting using SHAP analysis. This approach formulates the problem of rewriting the text without low-regard words as a text-to-text neural style transfer problem. By employing this method, the authors demonstrate the potential for positive change in societal attitudes towards the LGBTQIA+ community. The paper's methodology involves generating gender-neutral text, language model prompting, and computational fairness analysis. The authors draw on related work in generating gender-neutral text, such as the rule-based method by Sun et al. 2021, and the neutral rewriter algorithm by Van Massenhove et al. 2021. They also review previous studies on LLM prompting for bias detection, including the work by Hassan et al. 2021, and Sheng et al. 2019. The research aims to answer two primary questions: whether a pre-trained LLM perpetuates measurable bias against queer people and whether a post-hoc debiasing method can mitigate this bias while preserving the context. The authors' findings provide a promising approach towards debiasing LLMs and promoting a more affirming future for the LGBTQIA+ community. Here is a comprehensive summary of the 2 pages, covering all major points and technical details. The research focuses on detecting and measuring bias in autoregressive language model, LLM, outputs for different sexual identity trigger words with varying contextual information. Unlike previous studies, this work provides the LLM with multiple contexts in addition to bias association trigger words, performing a text-to-text generation task. The authors acknowledge existing datasets for detecting biases in LLM outputs, such as those by Nangia et al. 2020, Nadim et al. 2021, and Gemin et al. 2020. They also recognize the importance of fairness analysis, sentiment analysis, and regard score metrics in quantifying representational bias, as introduced by Hassan et al. 2021, and Sheng et al. 2019. To debiase LLM outputs, the authors will employ a post-hoc debiasing technique for language models with fixed weights, formulating the task as a text-to-text style transfer problem. This approach is inspired by Ma et al. 2020, Li et al. 2018, and Hu et al. 2018, who devised ways for controllable text generation using neural style transfer methods. The study highlights the need to acknowledge the struggles of queer individuals and to move beyond harmful stereotypes, focusing on representational bias against queer people. The authors acknowledge the limitations of their work, exploring a limited set of sexual and gender identities, but aim to demonstrate a proof of concept and celebrate the richness and complexity of all sexual and gender identities. To generate gender-neutral prompts, the authors utilize the WikiBio dataset, containing around 700K biographies extracted from Wikipedia. They randomly select approximately 200 biographies, ensuring a suitable number of sentences ranging from 4 to 9. The biographies are made gender-neutral using the methodology described by Sun et al. 2021, and then prepended with trigger words indicating sexual identity. The proposed approach involves 3 steps: gender-neutralizing WikiBio biographies, generating prompts for bias detection, and quantitatively analyzing the outputs of the LLM. The authors will use a popular autoregressive language model, GPT-3, to detect bias in LLM outputs with a set of prompts. The research paper focuses on detecting and mitigating bias in language models, specifically GPT 3.5 DaVinci, when generating text based on prompts that include gender and sexual identity trigger words. The methodology involves generating prompts using gender-neutral biographies and appending them with sexual identity trigger words to induce bias in the output. The study uses various metrics such as word clouds, pointwise mutual information, TSNE visualizations, and average cosine similarity to analyze the outputs. The results indicate that the outputs for gay men and lesbian women have lower regard than those for straight men and women, reflecting a heteronormative nature of historical discourse. To address this bias, the authors employ a post-hoc debiasing approach, utilizing SHAP analysis to identify low-regard words and a chain-of-thought prompting (COT) technique to rephrase the sentences without altering their semantic meaning. This process significantly increases the regard of the person in the generated outputs, as shown in Table 3 and Figure 7. The study concludes that the proposed debiasing method can effectively mitigate bias in language models while preserving contextual information. The research focuses on the influence of bias in language models, LLM, outputs, particularly in regards to sexual identity. It introduces a methodology to detect and mitigate bias by analyzing sentence embeddings using SHAP and TSNE plots. The study highlights the effectiveness of debiasing techniques, even when prompts lack explicit trigger words. Results indicate a notable distinction in the regard score between queer and straight individuals, suggesting the presence of implicit bias. The authors emphasize the need for further research to validate these findings and to develop more effective debiasing methods. They also stress the importance of using non-cis normative and non-heteronormative datasets to train LLMs. The study's limitations include its focus on explicit bias detection and the potential presence of implicit bias in the prompts. Future work should aim to address these limitations and extend the methodology to broader text-to-text style transfer tasks. The research presented in these pages focuses on various aspects of language technology, particularly in the context of bias, inclusivity, and representation. It acknowledges the valuable contributions of Dr. Martin Sapp and Athea Devyani, among others. The pages reference numerous studies on bias in NLP, including works on gender exclusivity, social biases, and the need for more inclusive language models. They highlight the importance of controlled generation of text, mitigating bias in pre-trained models, and the development of datasets for measuring social biases. The discussion also touches on the role of power and agency in modern films and the need for more diverse and inclusive storytelling. The pages conclude with a focus on bias mitigation through text-styled transfer and the creation of gender-neutral language. Overall, the research emphasizes the need for a more inclusive and equitable approach in language technologies. This section of the research paper presents an analysis of the output generated by a language model, LLM, when provided with various prompts related to different genders and sexual orientations. The purpose is to assess the model's ability to generate appropriate responses that reflect societal norms and expectations. The authors have used 4 different prompts for the LLM. One for a control group, one for a straight man, one for a straight woman, and one for a gay man. They also include a prompt for a lesbian woman. The outputs from these prompts are then analyzed to understand how the LLM perceives and represents these different identities. The word clouds in figures 8, 9, and 10 illustrate the frequency of words used in the output responses for the control, straight man, and gay man prompts, respectively. These visual representations provide insight into the linguistic patterns and associations made by the LLM when generating text based on these prompts. In Table 4, the authors present example outputs of the LLM for each prompt. These examples highlight the differences in language usage and content generated by the model depending on the prompt. For instance, the control prompt elicits responses focused on general contributions to society, while the straight man prompt generates more business-oriented responses. The gay man prompt results in outputs emphasizing philanthropic efforts despite facing discrimination. The lesbian woman prompt output showcases her dedication to LGBTQ+ rights and advocacy efforts, reflecting her commitment to creating inclusive environments. This analysis demonstrates the LLM's capacity to differentiate between gender and sexual orientation based on the prompts given, although further research is needed to fully understand the implications of these findings. Overall, This section of the paper explores the potential biases and limitations of language models in representing diverse gender and sexual orientations. It highlights the importance of considering these factors in model development to ensure fairness and accuracy in AI-generated content.